Welcome to Lab. In this channel, you will learn the basics of mathematics as well as the art of problem solving to prepare for the math competitions such as AMC8, MOEMS, MathCont, etc. Enjoy!
Hello folks! In this episode, we will show you exponents of fractions. You will learn rules on arithmetic operations on fractions, raised to a power, and negative exponents. Let's take a look. Let's look at the first rule for when we have a fraction raised to the power of n. When that happens, it's equivalent of the numerator raised to the power of n over the denominator raised to the power of n. So if I have a fraction a over b, the whole thing raised to the power of n, that is equivalent to a raised to the power of n over b raised to the power of n. Now keep this in mind. Let's look at a few quick examples. So say that if I have 3 over 5 raised to the power of 3. That is equivalent of 3 raised to the power of 3 over 5 raised to the power of 3. Now 3 raised to the power of 3 is equal to 27, and 5 raised to the power of 3 is 125. So the whole thing evaluates to 27 over 125. Let's look at another example. Minus 3 over 2 raised to the power of 5. So again, following the rule, that is equivalent of minus 3 raised to the power of 5 over 2 raised to the power of 5. Minus 3 raised to the power of 5 is negative 243. 2 raised to the power of 5 is 32. In our second rule, if I have a fraction a over b raised to the m's power and multiplied by the same fraction raised to the nth power, then we can combine these two together, and the result is equal to this fraction, which is a over b raised to the power of m plus n. And if we look at the rule from our previous slide, that can be further evaluated into the numerator a raised to the power of m plus n over the denominator b raised to the power of m plus n. Okay. So let's look at an example. In this example, we have 1/2 raised to the power of 3 multiplied by 1/2 raised to the power of 2. So following the rule, we can combine these two together. That gives us 1/2 raised to the power of 3 plus 2, which is 5. So we get 1/2 raised to the power of 5. Okay. And that, using the first rule, is equivalent to 1 raised to the power of 5 over 2 raised to the power of 5. Okay. 1 raised to the power of 5 evaluates to 1. 2 raised to the power of 5 evaluates to 32. So the final answer is 1 over 32. Now let's look at a negative exponent rule. If I have a fraction a over b, the whole thing raised to the power of negative n, which is a negative exponent. To convert this into a positive exponent, the base fraction has to be in its reciprocal form. That is, a over b raised to the negative n is equal to b over a raised to the power of positive n. Let's look at an example. If I have a fraction 4 over 3, the whole thing raised to a negative 3. To convert it into an exponent that is raised to the power of 3, then we have to inverse the base fraction. That is, 4 over 3 becomes 3 over 4. So that's equivalent to 3 over 4 raised to the power of 3. Now if we apply the first rule, that is equivalent of the numerator raised to this power and the denominator raised to this power. So that becomes 3 raised to the power of 3 over 4 raised to the power of 3. That equals to 3 raised to the power of 3 is 27 and 4 raised to the power of 3 is 64. So the answer is 27 over 64. Now let's look at another example. We have a fraction 1 over 3, the whole thing raised to the power of negative 3. And we want to evaluate it. Okay. So our first step is to convert the negative exponent into a positive exponent. Okay. So that means we're going to inverse the base fraction. So the inverse of 1 over 3 is 3 over 1. Okay. So the whole thing becomes 3 over 1 raised to the power of 3. And again, this is equivalent of 3 raised to the power of 3 over 1 raised to the power of 3. 3 raised to the power of 3 is 27. 1 raised to the power of 3 is 1. So 27 over 1 is 27. And that is our final answer. Let's look at our fourth rule. If I have a fraction where its numerator is a to the mth power and its denominator is a to the nth power, then this fraction can be rewritten and simplified into a raised to the power of m minus n. Okay? So let's look at some examples. If I have 8 squared over 8 cubed, now both the numerator and the denominators are exponents and they have the same base. So this can be simplified into 8 raised to the power of 2 minus 3, following the rule. Okay. So 2 minus 3 is equal to negative 1. So what we have is 8 raised to the power of negative 1. Okay. So we have a negative exponent, and we're going to convert it into a positive exponent. To do that, the base where the exponent is applied to is going to be inversed. So the inverse of 8 is 1 over 8. So that becomes 1 over 8 raised to the power of 1, which is 1 over 8. And that is the answer. Let's look at another example. In this example, we have a fraction 1 over 8, the whole thing raised to the power of 2, and then over 1 over 8 raised to the power of 3. So if you look at this fraction and then you look at the rule, okay, so we can simply say that in the rule where the letter a represents the fraction 1 over a in our example. Okay. So applying the rule, what this simplifies to is 1 over 8, the whole thing raised to the power of 2 minus 3. Okay. And that results in 1 over 8 raised to the power of negative 1. So again, we have a negative exponent, and we're going to convert it into a positive exponent. And to do that, we're going to take the base fraction and then get the inverse of it. So 1 over 8, its inverse is 8. So that becomes 8 raised to the power of 1. And that is 8, which is our answer. Now let's look at our fifth rule. If we have a fraction 1 over 8, the whole thing raised to the power of n, that is equivalent to 1 over a raised to the power of n. So here this step is quite similar to what we discussed in rule number 1. Okay. Now further simplification, this will give us a raised to the power of negative n. Now let's look at an example on how we can use this rule in our simplification process. Say that I have 1 over 5, the whole thing raised to the power of 3, and we want to evaluate this expression. So here, if you look at this, and referring back to the rule, if we do a reverse substitution, the letter a in the rule is equal to 1 over 5 in our example. And the power n in the rule is equal to 3 in our example. Okay? So keep this in mind that we have a is equal to 1 over 5 and n is equal to 3. Okay? So using the rule, what we have is we have 1 over a raised to the power of 3. Okay? And following the rule, this is equivalent to a raised to the power of negative 3. Now we're going to substitute the 1 over 5 into a. So that becomes 1 over 5 raised to the power of negative 3. So we have a fraction raised to a negative exponent. And the first thing we're going to do is convert the negative exponent into a positive exponent. So that means we have to inverse the base fraction. So the inverse of 1 over 5 is 5. Okay? So that becomes 5 raised to the power of 3. 5 raised to the power of 3 is 125. So that is the final answer for this example. Let's look at our final rule on an exponent of an exponent. Okay? In this rule, if we have a fraction a over b that is raised to the power of n, now the whole thing is again raised to another power of m. Then to simplify this, it becomes this fraction a over b raised to the power of n multiplied by m. So let's walk through an example. If I have a fraction 3 over 2 that is raised to the power of negative 2, and the whole thing is raised to the power of 3. So using the rule, this can be simplified into the same fraction, which is 3 over 2, is raised to the power of the first exponent, negative 2, multiplied by the second exponent, 3. So it's negative 2 multiplied by 3. And if we simplify that, that's equivalent to 3 over 2 raised to the power of negative 6. So here we have a fraction raised to the negative exponent. And we're going to use our negative exponent rule. To convert this negative exponent into a positive exponent, the base fraction will be inversed. So that becomes 2 over 3 raised to the power of 6. Using our first rule, this is equivalent to 2 raised to the power of 6 over 3 raised to the power of 6. And that is equal to 64 over 729.